Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, for today's lesson, we are going to focus on the subtraction of integers. And to do that, we're going to work with integer tiles again. And so just to clarify the meanings of these integer tiles, the plus sign represents a positive 1 or plus 1. So 1 positive here, and then this minus sign represents negative 1. And if you recall the idea of a zero pair, maybe I'll write these guys in. These are examples of zero pairs, where if you take one positive with one negative, you add them together, you're going to get 0 for an answer. Okay, so let's get to the lesson. In chapter 2, you worked with adding and multiplying integers, positive and negative, whole numbers, and 0. In this lesson, you will use the plus and the minus tiles to learn about subtraction of integers. Keep the following questions in mind as you work with your team or as you work on your own today. At the end of the lesson, you will discuss your conclusions about them. Okay, so how can we remove negative tiles when the collection only has positive tiles? That's an interesting question. You know, one of the things I always tell students, and we'll get more into this into the next lesson, is subtracting is not easy. I mean, you've got to have something there to begin with in order to take it away. That's what makes subtraction a little bit more complicated than addition, because you can add anything together. And then, you know, if you're adding positives and negative together, they form some zero pairs that, you know, you can sort of ignore. But to subtract something that isn't already there, how do you take it away if it's not already there? So today we're going to talk about that a little bit, some strategies that we can use. How can we think about subtraction when there are not enough to take away? Same kind of idea. And then when does subtraction make the results larger? That's an interesting idea. The fact that you take something away and what you have as a result is more than what you started with seems impossible, right? But when we start looking into the mathematics and the logic of integer operations, you'll see that it's not. Okay, so let's start off with an assortment of tiles. Please copy down this assortment of tiles, and if you want to, notice how there's 1, 2, 3, 4 positives and 1, 2, 3, 4, 5, 6 negatives. You don't necessarily have to draw it the way that it's assembled here. You can organize them if you want to a little bit and put all the positives and negatives in a row together. And as you can see, you know, when you do it this way, we've got 4 positives and 6 negatives. Well, the 4 positives and the 4 negatives combine to make zeros, right? So we got 0 plus 0 plus 0 plus 0 plus 2 negatives. So what does this assortment represent? Well, it represents -2. What would happen if 3 of the positive tiles were removed? How can you use numbers and symbols to represent this action and the resulting value? Okay, so what you can do on your paper is if you've created this assortment of tiles, you can do something like this. You could say, all right, I'm going to, what are we removing? 3 positive tiles. So it's like, okay, well, that's no longer there, that's no longer there, that's no longer there. And this results in a 0 pair, correct? Or you could actually, if you had pluses and minuses like we were in classroom, you could say, okay, I'm going to remove 3 of these tiles. There goes 1, there goes 2, and there goes 3 of those positive tiles. Now we've still got this 0 pair here, but what do we have left over? We have -5, correct? So this is like taking a number sentence and saying we started with -2, right? Because that was the value of all of these tiles up here was -2. Then we took away 3 positives. So -2, what is going on there? Ooh, I guess I'll have to write it back in. Sorry. So you started with -2, you took away 3, and what do we have left over? 1, 2, 3, 4, 5 negatives. So your answer is -5. So -2 minus 3 is equal to -5 when we use the logic of these integer tiles. Okay? I'll put these guys back to where we started. Move you up a little bit. All right, let's take a look at this one. What happens if 3 negative tiles are removed from the original tile set. Okay, so once again, you're starting with -2, but now you're going to take away 3 negatives. What is your resulting answer when that happens? Okay, so we take away this negative, I'm going to take this negative away, and I'm going to take this negative away, right? And don't forget, these guys are all zero pairs, so they're not really changing anything. So what do you have left over? -2 minus a -3 is equal to +1. So a lot of times students are confused by these types of subtraction problems, especially this one when you got all those negative symbols. But if you can model this situation using the integer tiles, it makes sense, right? Take away 3 negatives, you only had 2 negatives to begin with. So by taking away 3 negatives, that left you with a number that was greater than what you started with, right? And it's like, okay, how can we make this make sense? You know, I mentioned it before. I used to teach fifth graders, and I taught for 6 years in fifth grade, and they were just being introduced to the idea of positive and negative numbers. And one of the students had a teacher that had explained it this way, and I really liked what she had to say. And she said, think of a community, okay? When you take away bad people and send them to jail, that's a positive result for the community. So taking away a negative is like adding a positive. And so in those terms, here we started with -2 and we took away 3 negatives. That had a positive net result on the overall value of what it was we were working with. Okay, so if you can think about it in those terms, it starts to make a little bit more sense. But this is going to be one of those things where you just got to sort of trust the process, work through the process, and eventually it's going to start to make sense. Now, tomorrow's lesson, I'm going to actually teach you a process to change the minus sign to a plus sign. Because subtracting is confusing. People don't like doing it. It's really hard, the idea of taking away something that isn't already there. But adding things, anybody can add stuff. Okay, but that'll be tomorrow's lesson. Let's just focus on manipulating these tools and these positive and negative integers to help illustrate why we do what we do and how we get the answers that we get when we're subtracting positive and negative numbers. Okay, so it is often useful to represent operations and expressions in multiple ways. These might include diagrams, numerical expressions, writing it out in words, showing what the new total is. So in each of these parts, A, B, and C, one representation is given. Here, for A, you start with a visual representation of the positive and negative tiles, a diagram, if you will. In part B, we're given a numerical expression. And in part C, you're given a word problem where it's given to you in words. So what we want to do is take each one of these situations. If there's, for A, let's write a numerical expression and the answer. For B and C, let's create both models. Well, actually, B, you're going to create a model and the answer. And for C, you're going to do both from the words. Okay? Or maybe I wrote in words here. I can't remember what I did. Okay, so start by copying these 3 problems down. And I know C is a little wordy, but pause and just take a little bit of time. I promise you this is not going to be the longest lesson we have. I'm going to shoot for 15 minutes or less, okay? Pause, and then when you're ready, unpause, and I'll reveal what I have for the answer. Okay, for A, does everyone agree that we're starting with 8 here? Because you got 1, 2, 3, 4, 5, 6, 7, 8 positives, and these 2 zero pairs don't change the value of anything. So this is 8. But then what did we take away? Circling this and pointing the arrow implies that this is the amount that's going away. So we started with 8, we took away 2 negatives, and what does that leave us with after those negatives are gone? You still have those 2 positives from the zero pair combined here with the 8 to give us a total of 10. So 8 minus -2, or when you start with 8 and you take away 2 negatives, you end up with 10 for your answer. Here we started with -8. and then we tried to take away 3 negatives. Now, if you start with 8 negatives, you can take away 3 negatives, right? That's not too much trouble. So started with 8 negatives, took away 3 of them, and you're left with 1, 2, 3, 4, 5 negatives. So your answer to this problem is -5. And then in the last situation, it is cold. The first time I looked at the thermometer today, it said, it shouldn't be a thermostat or whatever. Maybe not. It said it was 0 degrees Fahrenheit. Then it dropped or went down 5 degrees. So if you think about that, we started at 0 and took away 5, it dropped 5 degrees. So that means that our new temperature must be -5, correct? Well, how can you take away 5 if you start with nothing? Well, enter the 0 pairs. If we start off with nothing, that's like you can have an infinite number of 0 pairs. But all we really need to do is create 5 0 pairs, right? A positive plus a negative makes 0, and 0 plus 0 plus 0 plus 0 plus 0 equals 0. So this technically is 0, but I've got enough 0 pairs to where I can take away 5 positives. And what does that leave me with? 1, 2, 3, 4, 5 negatives. So our answer is -5. And let me draw a nice little box around that since I'm boxing in my answers. Okay, so using a little bit of logic with our tools can help us solve problems that otherwise, might have seemed confusing. And I know many of you understand how thermometers work and thermostats. And I guess a thermostat controls the temperature. I'm sorry, I'm off topic. Let me stay on topic. Yeah, so the idea of taking 0 -5 on a number line might make sense to you, might actually make more sense in this process, but this is how you would illustrate it with integer tiles. All right, so what we're going to do now is you're going to copy down all 6 of these problems. Then I would like for you to construct the integer tiles. Draw the pictures. For instance, I'll do A for us. We started with 7 and we're going to take away 5. So that's 7 minus 5 positive tiles, right? So we started with 7, 1, 2, 3, 4, 5, 6, 7. We removed 5 positive tiles. What does that leave you with? Leaves you with 2 positive tiles. So your answer to 7 minus 5 is 2. And you look at that and it's like, well, yeah, we've been doing that since first grade, right? I knew what 7 minus 5 was. Well, here's the model for it. This proves that that works, okay? So I'd like for you to copy down B, C, D, E, and F. Copy down what I did here so you see that that's the model for what you need to do. And go ahead and see if you can create the integer tile models and the little description in words for what this means. And I'll give you a hint. You started with 0 and you're removing 4 positive tiles. Here you're removing 2 positive tiles. And here you're removing 4 negative tiles. Okay, go ahead and pause. Come back when you're ready and I'll show you, I'll reveal what I have for the answers. All right, so for 0 minus 4, and you might be asking, how can you take away 4 if you don't have anything? Well, that's where you've got to create your 0 pairs. So 4 0 pairs so that you have enough positives to take away or remove 4 positive tiles, which leaves you with -4 as your answer. 0 minus 4 is -4. Started with -6 and you took away 2 positives. Well, are there any positives there? No. So you're going to have to create a couple of 0 pairs so that you have enough 0 pairs to take away 2 positives. So here are 1, 2, 3, 4, 5, 6. And then I didn't write them next to each other, but can we all agree that 2 negatives and 2 positives makes 0? So that has a total value of -6. After you remove the 2 positive tiles, now it's 1, 2, 3, 4, 5, 6, 7, 8 negatives. So -6 minus 2 is equal to -8. How about this one? You started with 3 positives, but you have to take away 4 negatives. Well, if you don't have 4 negatives to take away, you're going to have to add some 0 pairs. So we start with our 3 positives and then 4 0 pairs. So 3 plus 0 plus 0 plus 0 plus 0 is 3. But now that we have 4 0 pairs, we have enough negatives to remove the 4 negative tiles. So So 3 minus a negative 4 ends up giving us an answer of 1, 2, 3, 4, 5, 6, positive 7. For E, you've got to start with 8 negatives, and then you're going to take away 5 of those 8 negatives. So in this case, we don't need any 0 pairs because we've got enough negatives to remove 5. So we remove 5 negative tiles, and what does that leave us with? 1, 2, 3 negative tiles. So our answer to negative 8 minus a negative 5 is negative 3. And for the last problem, you're starting off with 1 negative, and you're supposed to take away 9 negatives, but you don't have 9 negatives to take away. So once again, you're going to have to create some 0 pairs. So here's what we got. We got a total of 1, 2, 3, 4, 5, 6, 7, 8 0 pairs. And then in those 0 pairs, you've got 8 negatives plus another negative, makes a total of 9 negatives that can be taken away. So once again, you got 0 plus 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 0, and a negative 1. The total value was negative 1 before we took away 1, 2, 3, 4, 5, 6, 7, 8, 9 negatives. And after those 9 negatives went away, we were left with 8 positives. So negative 1 minus negative 9 is equal to positive 8. Okay, now, can we all agree that these subtraction problems can get very complicated, especially C, D, E, and F? That's where the next lesson that we do, I'm going to show you a trick that's going to make your jobs much, much easier, okay? So we're going to go back to, there's some other problems in this lesson, but I don't want to, they get kind of complicated, and I think a little too complicated too soon. So let's just stop it there. What time do we have? I thought 15 minutes, but no, it's going to go up to closer to 20. Okay, these 3 original questions that we had at the beginning. How can we remove negative tiles when the collection has only positive tiles? Well, have you given that much thought? What did we do when we had a collection of tiles, but we were trying to remove some that weren't already there? What did we have to add? Excuse me, I just burped. That's terrible. What did we have to add? We had to add 0 pairs. So here's an example of a situation like that. If we started with 3 and we tried to take away 2 negatives, how can we do that? You can't until you add a couple of 0 pairs. And so once you take away the 2 negatives now, our answer is going to be 5. Okay, so 3 minus a negative 2 is positive 5. How can we think about subtraction when there are not enough to take away? Well, sometimes you can think about adding the opposite. And this is going to be kind of what we do in tomorrow's lesson, where instead of thinking of taking away 2 negatives, what if we were to change that to, instead of 3 minus a negative 2, to change it to 3 plus a positive 2? So instead of subtracting a negative, if we add the opposite of whatever was being subtracted, is that a legal move? You get the same answer. That's going to be something for us to explore a little bit more in our next lesson. So when does subtracting make the result larger? When you subtract a negative, your amount will always get larger. Think about when you remove a bad guy from the neighborhood, how that makes the neighborhood safer. That's a good thing. You take a bad person to jail, jail is bad, but you're removing the bad, so that's good for the community, okay? So go ahead, jump into your homework, show your work. If they ask you to create the models, I highly recommend you create those models, because this is a very powerful tool to help you understand why we do what we do when we subtract positive and negative numbers, okay? All right, good luck on the homework. We'll go into the next lesson maybe tomorrow, or I don't know when the next lesson is going to be, because I don't know if it's Thursday or if it's Monday or Tuesday. So on to the next lesson. Bye-bye.
Hey, feeling